Let's talk about stoichiometry problems. These are those problems that involve mole to mass as well as mole to volume calculations. In exam contexts like IGCSE and A level, they are usually grouped under stoichiometry and the mole concept, gas volume calculations at room temperature, as well as quantitative chemistry, which include percentage yield, percentage purity, sometimes concentration, as well as titration. All right, so let's dive into question number one, the question that we have here. That is gonna actually help us to understand some concepts about stoichiometry. All right, so this question, let me try to zoom out. Yes, I think it's you can see it clearly. The question here says, the question reads, if 8 grams of sulfur are burnt, what volume of sulfur dioxide is produced? Assuming the reaction is done under RTP. RTP here means room temperature and pressure. I'm going to read the question again. If 8 grams of sulfur are burnt, what volume of sulfur dioxide is produced? Assuming the reaction is done under room temperature and pressure. Right, what do we have here? Basically, what we have here, let's just maybe underline the thing that we're given in our question. If 8 grams of sulfur are burnt, so we're looking at 8 grams of sulfur, and then we are having here burnt. It means this sulfur is undergoing what we call the combustion reaction. So it's burning. This sulfur is burning in oxygen, in other way. So this sulfur is burning in oxygen. Why do we know? I mean, why are we saying that it's burning in oxygen? Because at the end there we're having the product, which is sulfur dioxide. So it is the moment we have sulfur dioxide, it is only when sulfur is burning in oxygen. Okay, so we're just looking at our product, and then we are having, I mean, we are having the clear picture that this sulfur is burning in oxygen. So the 8 grams of sulfur, they are burnt in oxygen, and then we are producing sulfur dioxide, or sulfur dioxide is produced. Now, assuming that this reaction is taking place under, or is occurring under room temperature and pressure, what volume of this product is produced? So what volume of this product is produced? All right, so let's try solve this problem. What do you think? What do you think is the first step in solving this problem? So you can pause the video and then try to solve it and relate with what I'm gonna show you right now. All right, so let's try solve it. All right, so remember, when we are given these kind of questions, the first thing to do is to make sure to come up with the we come up with the equation, the correct chemical equation. Okay, because already we do have the weight equation here. Sulfur are bent they are bent, and this sulfur is bent in oxygen. So let's see. First, perhaps you can just write the weight equation. Let's see. You're having sulfur, and then there is oxygen, and if you have these two, what are you having? You are producing here sulfur dioxide. So you can write the weight equation this way. All right, after weight equation, we can come up with the correct simple equation. So you know sulfur is represented by letter S, and then plus oxygen, this is gas, so it's O2. This one is producing sulfur dioxide, so it's sulfur SO2, like that, sulfur dioxide. That's the first step. The first step here is to come up with our chemical equation, and now we come up with this kind of chemical equation. Always, I'm saying always in chemistry, when you come up with chemical equation, you must make sure that it's correct. And then after making sure that it's correct, go on and try to balance the whole equation, all right, if it's not balanced. So let's see here. On the right hand side we're having, left hand side we're having sulfur only 1, and then this is 1 only sulfur, and then this is O2 and this is O2. So our equation here is balanced, no need to struggle there. What do we need to do? So after here we are supposed, because remember we want to find the volume of this. Okay, the question says what volume of sulfur dioxide is produced. So we want to find this volume, but we are assuming that this reaction is occurring at room temperature and pressure, RTP. Okay, so already there is a key there. We're going to look into that kind of key we are given. All right, now sulfur plus O2 equals SO2. Sulfur plus oxygen is giving us sulfur dioxide. The first step to do here, it's basically to calculate the number of moles of sulfur. Okay, the number of moles of sulfur. So we are starting from here, because this is what we are given. There is something that we're given here. We are given mass of sulfur. The mass of sulfur, which is 8 grams, and these 8 grams are being bent into this kind of oxygen that we're given there. So we are given this, at least this is what is known. So we start from the known and then we go to unknown. So because we have mass of sulfur, which is 8 grams, basically we can also find the molar mass of sulfur. So molar mass of sulfur is simple. If you just check into your periodic table, you find that that molar mass is 32 grams per mole. So if you have these two, mass from the question and the molar mass, you can do some kind of mathematics here for you to come up with the number of moles. So the number of moles of sulfur here is equal to mass, which is 8 grams, divided by molar mass, which is 32 grams per mole. So if you do this, you're gonna find your number of moles to be something else like 0.25 moles. So this is the number of moles of sulfur. Okay, so that's the number of moles of reactant. Simple. Now what next? The next step to do here is to actually relate. It's just to make sure that we find the number of moles of sulfur dioxide that are formed. How are we going to know this? From the balanced chemical equation, we know, right? We know, or else you can just see here. Look at this. The coefficient here for this sulfur is just 1. And therefore, the coefficient of this also sulfur dioxide is just 1. So there is 1-to-1 kind of relationship there. Okay, so we just have to relate to say if there is 1-to-1 relationship in the equation, therefore this implies that 1 mole of sulfur mixed, or they're being bent, is being bent into oxygen, which is 1 mole of oxygen gas, giving us 1 mole of sulfur dioxide. So since we're just focusing on sulfur and sulfur dioxide, we are basically going to look at this kind of ratio, sulfur and sulfur dioxide. So let's just dive right into it. So if we are saying here that 1 mole of sulfur is giving us 1 mole of sulfur dioxide, how about 0.25 moles of sulfur? How many moles of sulfur dioxide are we going to have? So since the relationship is just 1-to-1, therefore we are just going to say, so here 1 mole of sulfur is giving us 1 mole of sulfur dioxide. So this implies, or else so here, so, or this implies that 0.25 moles of sulfur is also going to give us 0.25 mole of sulfur dioxide. As simple as that. Okay, so now we know the number of sulfur dioxide to be, the number of moles of sulfur dioxide is what? Is simply 0.25 moles. So this is our number of moles of sulfur dioxide. How have we known that? We are just coming from the relationship that is found in the chemical equation. You see, the good thing of having the chemical equation which is balanced. So always make sure that your chemical equation is balanced. Now, from here, what are we going to do? We are going to find our volume. Remember, we are given a key. What is a key? The key is room temperature and pressure. So at room temperature and pressure, let me get that one again. So we are saying at RTP, what do we know at RTP? At RTP, we know that 1 mole of any gas, 1 mole of gas, of any gas gives us 24 cubic decimeter. That's what we know, right? This relationship is in chemistry. You just have to know it. And most of the times during IGCSE exam, this is a key which is found at the periodic table there. Okay, so 1 mole of gas gives us 24 cubic decimeter, or occupies 24 cubic decimeter. Okay, that is a volume. Now, how about 0.25 moles of sulfur dioxide? So how about 0.25 moles of sulfur dioxide? Okay, so what I'm going to do is simple. We just have to multiply that one. So we're just going to multiply. Therefore, the volume of sulfur is going to be 0.25 moles multiplied by 24 cubic decimeter per mole. Okay, so we have here this mole, is gonna cancel with this mole, right? We're gonna multiply these two numbers. We're gonna multiply these two numbers, like the 0.25 and 24 cubic decimeter. So the answer that we're gonna find here at the end is gonna be something else like 6. Let me use my calculator here. It's gonna be 6. All right, so we say 0.25 multiplied by 24. Yes, 6. So our response is gonna be, or our answer is gonna be 6 cubic decimeter. So this is gonna be our answer. Okay, good. So that's how we solve for this kind of random stoichiometry problem. Okay, that's how we solve it. So remember, what was our question? Our question is coming all the way from above here. Okay, so you see, look at this. Look at this. You say, if 8 grams, look at this question. If 8 grams of sulfur are burnt, what volume of sulfur dioxide is produced, assuming the reaction is done under room temperature and pressure? So what I've done, first stage is to write down the equation. So you can start with the word equation if you're not familiar with the direct chemical equation, simple equation. So after word equation, you come up with the what? You come up with the chemical equation. From the chemical equation, you come up with the relationship. I mean, the number of moles of this sulfur, because we are given. So you do this, and after finding the number of moles of sulfur, you relate in the equation. You find the number of moles of sulfur dioxide. So the number of moles of sulfur dioxide is going to be something else like 0.25 moles, because there was 1-to-1 relationship there. And at room temperature, 1 mole of gas occupies 24 cubic decimeter. How about 0.25 moles? Is going to be less, so we just have to multiply, and then we're going to have this kind of response there. Okay, good, simple, right? All right, now what should I do here? Let's say we are given this kind of the same problem, I don't know, the same, or just similar. All right, so let's flip the style of the question. So instead of giving the mass of the reactant and asking for the volume of gas, we give the volume of gas and ask for the mass of reactant. All right, so I think I pasted the question here. Where is the question? Somewhere else here. There is a question. Yes, the question is already here. Okay, look at this question, people. Look at this question. It says here, what mass of sulfur is required to produce 12 decimeter cubed, or 12 cube decimeter, whatever. This is really hard to say, cubed or cubic or something like that. We're chemistry people, right? What mass of sulfur is required to produce 12 cubic decimeter of sulfur dioxide gas at room temperature and pressure? For just clear understanding, I'm still using the same kind of equation. Okay, the oxygen produce sulfur dioxide, for you to understand it very well. Otherwise, you can try with other kind of items, or elements, atoms, whatever it is. So what mass? Here we're asking the mass of sulfur. Now we're coming from the right, we're going to the left. What mass of sulfur is required to produce 12 cubic decimeter of sulfur dioxide gas at room temperature and pressure? So what we are going to do here, simply we're going also to follow the same steps. Number one, to write down the equation, and our equation must be well balanced. So this time I'm gonna choose green. I think that's green. Okay, first write down the equation. Okay, what is the equation? The equation is gonna be sulfur plus oxygen, that's O2, producing sulfur dioxide. Good, we're good here. Now that's the equation. Now the question is, what mass of sulfur is required to produce 12 cubic decimeter of sulfur dioxide gas at room temperature and pressure? So this time we're given this side. What are we given? We're given volume, which is 12 cubic decimeter. All right, the volume that has been produced, remember it is at room temperature and pressure, so already this volume has been produced at room temperature and pressure. We need to find the mass of this, so it means we're gonna start from where we know to where we don't know. Okay, so that's gonna be the thing, from known, remember, from known to unknown. So it's kind of easy in physics, chemistry, biology, mathematics. If you list down the things that you're given in a question, if you list down those things that are given in a question, even you don't know, even though you don't know the formula, it's gonna give you a clear picture of what you're supposed to do. All right, with the items that you've listed them down. Okay, good. So here, let's see what clue is this volume going to give us. This volume has been produced already. Okay, after the reaction of this and this, the volume has been produced, but the volume has been produced at what? At room temperature and pressure. So volume at room temperature and pressure of any gas is 24 cubic decimeter, and this 24 cubic decimeter is a volume of gas with how many moles? With only 1 mole. Okay, so 1 mole of any gas occupies 24 cubic decimeter at room temperature and pressure. So I think now you are trying to relate. In other way, 24 cubic decimeter volume is occupied by only 1 mole. How about 12 cubic decimeter volume of sulfur dioxide that has been produced? How many moles are in this sulfur dioxide? So we're gonna use these two. These are clues for us to come up with the correct volume. All right, correct number of moles. Good. Now, what are you going to do? Number one, we're gonna find the moles of sulfur dioxide from the volume. So this is how you can do step by step. Step number one, you can write at room temperature and pressure, right? 1 mole of any gas is equal to 24 cubic decimeter. Okay, right. Now, moles of, or just like this, you can just like this. Maybe I might confuse you. At room temperature and pressure, 24 cubic decimeter, okay, is occupied by 1 mole of any gas. How about 12 cubic decimeter of sulfur dioxide? How many moles are going to be, how many moles are occupying this volume? So it's simple. We're just going to kind of like divide there. So already, if 24 is giving us 1 mole, how about 12? It means it's going to give us less of the amount, less of 24, right? Yeah, so it's never going to be more than 1 mole. That's using the common sense there. So it's going to be 12 cubic decimeter divided by 24. Okay, my 24 is kind of crappy there. 24 cubic decimeter multiplied by one more, like that. Simple. So we are going to have these two things canceling each other. This is going to cancel this. We're going to remain with only number of moles there. So if you do this, this is not really 1.2, please. This is not 1.2. This one is 12. Okay, I think I need to make it clear there. Okay, it's 12. So 12, good. Now we are saying the answer 12 divided by 4 is just half, right? It's just half, it's 0.5. So the answer here is going to be 0.5 moles. So that's the answer. But this is not like the final answer, because these are just moles of sulfur dioxide, all right? These are moles of sulfur dioxide. So since we have found, coming from the equation here, since we have found the number of moles of our sulfur dioxide, it means we can also find the number of moles of this is sulfur. And then from this number of moles, we can find the mass of sulfur now. How? By using the relationship that is in the what? In the equation. Remember, in the equation, there is one-to-one relationship. Here, 1, 1, and 1. But we are focusing on this one and on this one. Okay, between this one and this one. So these two ones, they're just one-to-one relationship. Sulfur, one more sulfur is giving us one more of sulfur dioxide. So another way, 0.5 moles of sulfur dioxide is also going to give us what? 0.5 moles of sulfur. The same, very same thing that as we did with the last one, the previous. Yeah. So let's go down again. Oops. Okay. Here. So what are we going to do here? Moles of sulfur sulfur that is needed. So if you are like writing exam or something, you're gonna go step by step. You say from the balanced equation, or from the balanced equation. So from the balanced equation, we know, or we've seen, that one mole of sulfur is giving us one mole of sulfur dioxide. Okay, so just more than, so here, so 0.5 mole of sulfur dioxide simply is gonna give us 0.5 moles, 0.5 moles of sulfur. As simple as that. So it's going to give us 0.5 moles of sulfur. So in other way, these are the number of moles of sulfur we've calculated, we found them, we've derived them from the equation, okay, from the mole ratio itself. So because we now know the number of moles of sulfur, we're going to find the what? The mass of sulfur. So remember, what is our mass? The mass is just found by number of moles multiplied by molar mass, which can be presented by mr or just capital M, whatever way you can present that one, depending on the syllabus that you're following. So do we have number of moles? Yes, we have number of moles, because remember, this is for sulfur, right? So number of moles of sulfur is 0.5. We put moles there, and then we multiply this by molar mass of sulfur. What is molar mass of sulfur? We saw already this one. We already saw this one. This is like 32 grams per mole. So 32 grams per mole. Do not forget these units. They really give you a clue of what response you're going to find there. So it's like moles. It's going to cancel with mole. You can see this is over here. It means this mole is down. So we are going to remain with only grams, which is G. So our response, or our answer, is going to be 0.5 multiplied by, so this is 0.5, people. Let me just try to do this here, people. This is 0.5. I think you can see that. Since you're following me, so you know it. So 0.5 moles. So if you multiply 0.5 by 32 grams per mole, this is going to give us, like, it's going to half the 32. So it's simply going to give us 16 grams. So yes, that is our response, that is our answer. Okay, that's how we've managed to find our answer after flipping the style of the question from the so that it can be different from the question that we did at first. Yes, so that's how we've done it. Maybe a quick look of what we've done. You can see the watt mass of sulfur is required to produce 12 grams, 12 cubic decimeter of sulfur dioxide gas at room temperature and pressure. So what we've done first, we wrote down the equation, and then the balanced equation. It was already balanced, and then at room temperature 24 cubic decimeter equals to 1 mole of gas. And then how about 12 cubic decimeter? We are trying to find the number of moles of sulfur dioxide. We found number of moles to be 0.5, that is, and then from the balanced chemical equation we try to find the mole ratio, and we saw that sulfur to sulfur dioxide was just 1 to 1, and therefore 0.5 that applied to sulfur dioxide also applied to sulfur. And then we know the molar mass of sulfur, we just multiplied it by the number of moles that we found to find the mass, or the required mass. Yes, so that's how we've done it. Try to find other problems. I don't have the question right now, but find other problems that you can solve using the procedure that we've just done here in this question, or in this video. So try to find other things that will even help you to understand the concepts very well. So thank you very much. It's been the Impact Academics. Thank you for supporting. Thank you for following me up.